We are looking at the Unit 3 review, and this chapter covers parallel lines cut by transversals, and then our 4 angles once we have those parallel lines cut by a transversal. So in the first 6 problems, we're identifying the pairs of angles that we have. Just looking at the location and naming the relative pairs that are given. It even gives you the options of the ones that you have up there. So for the first one with 3 and 6, if we look at 3 and 6, they're on opposite sides of the transversal in between the 2 lines, so that would be alternate interior angles. 2 and 7 are outside the 2 lines on opposite sides, so that would be alternate exterior angles. 4 and 8 are in the same location. They're both in the bottom right of the intersection. When they're in the same location, they're corresponding angles. 5 and 8 are at the same intersection, and they're opposite sides of the vertex from each other, so those are vertical angles. Number 5, we have angle 3 and 5. Those are on the same side of the transversal, in between the lines, so we call those consecutive interior angles. And the last one, 1 and 8, outside the 2 lines, opposite sides of the transversal, that would be alternate exterior angles. Okay, now we're going to solve with those angle pairs. Number 7, we're looking at alternate interior angles, and we have alternate interior, they are equal. So 65 equals 3x plus 11. That, by subtracting 11 from each side, I get 54 equals 3x, so x is 18. In number 8, I have my 2 parallel lines here. My transversal goes through them. I'm looking at angles on opposite sides of the transversal outside the parallel lines. So those are alternate exterior. Alternate exterior are equal, so I set the 2 values equal. I'm going to distribute the 5. 5x minus 45 equals 3x plus 15. I can subtract 3x from both sides, gives me 2x minus 45 equals 15. I could then subtract 15. Now, but I add 45 to both sides. Get 2x equals 60, so x is 30. On number 9, I look at these angles, and these are actually none of the certain angle pairs that I have. But if I looked at the corresponding angles here, I can make this 2x minus 18. With that being the case, it makes them a linear pair, so they are supplementary. 2x minus 18 plus 24 equals 180. 2x plus 6 equals 180. 2x equals 174, so x is 87. Moving down, we're actually finding x, y, z in number 10. First thing I can find is x, because I have these 2 are alternate interior, so 2x equals 40, so x is 20. So actually I know that angle is 40 as well, and that helps me because then I can look at these parallel lines and this transversal to see that 40 and 4y minus 4 are consecutive interior, so they would be supplementary. So 40 plus 4y minus 4 equals 180. 4y plus 36 equals 180. I could subtract 36 from both sides, and I get 4y equals 144, so y is ultimately 36. And to get to z, well, we have a couple different ways to get there. I'm going to take this 40 and make the one next to it 140. And then by alternate interiors, I have z as 140. And you could have gotten there another way, but that's one that works for me. Number 11, we're going to actually break this into 2 parts. I have the left side, where these 2 are consecutive interior, so they're supplementary. I have the right side, where these 2 are consecutive interior, and they're supplementary. So 5x plus 90 equals 180, which means that 5x equals 90, which we could have technically said that from the beginning because we knew it was also going to be a right angle. But in that case, x is 18. And then for the right half, 4y minus 10 plus y equals 180. That's 5y minus 10 equals 180. 5y equals 190. and then I divide 190 by 5, and I get 38. Number 12, we have a little bit different approach to this one than we commonly use. But I can actually say that these two angles are supplementary. So I'm going to say that first. 4x plus, let's separate these here. 4x plus 5x plus 6y equals 180. I'm going to combine those terms and say 9x plus 6y equals 180. But we're kind of stuck here because we have two equations and one equation and two unknowns. We can't solve for that. So let's go back and get another equation. I know that 4x is equal to the 3x plus 6y because they are corresponding. So I'm going to say 4x equals 3x plus 6y. That tells me that x is equal to 6y, just by subtracting 3x from both sides. But now I can take the x and replace it with 6y, or substitution, in my equation. And that gives me 9 times 6y plus 6y equals 180. Ultimately becomes 54y plus 6y equals 180. 60y equals 180, so y is 3. I go back up here and plug that in. X equals 6 times 3, so it is 18. I guess you can see why we actually have to do this on a separate sheet of paper so we can fit it all in there. But we got what we needed. Okay, we go down to 13. 13 is a lot like number 11. We have two separate consecutive interior problems just combined into one. By the top half, I have that 120 and y are consecutive interior, so that means y needs to be 60 to add to 180. The bottom half, I have 130 and x are consecutive interior. That means y needs to be, or x needs to be 50 for it to be supplementary. On number 14, we're looking for x, y, z. Probably the easiest one to get there is y, because it is vertical to 32. So we get that one out of the way. The next one I see is 2x and 50. These are corresponding angles. And if I redrew just those, I'd have 2x and I'd have 50. So I can set those equal, and x is 25. So I just need to find z. And there's a few different ways we could find it. I always like to look at the most direct way that I see. And I notice that all three of these angles add up to 180. So I could say z plus 50 plus 32 equals 180. Z plus 82 equals 180. And we get that z is 98. Okay, go to our next page here. And I think these are important types of problems in these 15 through 19 because it's taking different sets of lines, and we have to identify, if we're given certain information, certain things to work with, which ones are parallel. So whereas it's important to make sure which ones are parallel, it's also important to make sure why they are parallel and knowing that reason. So let's go to the first one here. We have angle 1 and angle 11. I'm looking for a transversal they're both on. They're both on M. So they have that in common. They're on K and H. So if I have parallel lines, it's going to be K and H. So are they one of the angle pairs? Well, if 1 and 11 are the same, those would be corresponding angles. If corresponding angles are congruent, then I have parallel lines, so K is parallel to H, and that's by my corresponding angle converse. Now we look at 2 and 4. Well, the first thing we see is 2 and 4 are vertical angles. They're equal, and that's true for vertical angles, and they're where K and M meet, but they're not on separate lines. 1 and 11 were on separate lines, so they had something that could be parallel. We don't have that, so no lines are parallel. We can maybe make a note that they're vertical angles. Okay, 5 plus 7 equals 180. Well, if I look, they have H in common, and they're on M and N. But we should know that when we see that adds to 180, supplementary, we look for consecutive interior. These two are in fact consecutive interior, in between M and N, same side of H, so we can say that M is parallel to N, and that's the consecutive interior angle converse. Okay, next we look at 9 and 8. 9 and 8 are a linear pair and they're equal, which actually means they're both 90 degrees. So if the question asked which ones are perpendicular, by this problem we know that f is perpendicular to n. Unfortunately, that's all we know. We don't know anything else, especially about parallel, so for the sake of the question we'll say none. But if you notice they're perpendicular, that's a good thing. Last one we have is 3 and 4. 3 and 4 have m in common, and so it's k and f I'm looking at. So I can almost cover up h and ignore it. That's our last one. We'll cover it up. So they're opposite sides of the transversal, outside the lines, so if they work, they could be alternate exterior angles. They are the same, so we're going to say that k is parallel to f by the alternate exterior angle converse. Okay. Next we go down to number 20. We need to see if AB is parallel to CD. I know that parallel lines have the same slope. So first I'm going to find the slope of AB. Now slope is change in y over change in x, and you can always use slope formula, and that's perfectly fine, but if we just look at the actual change, I went from 2 to negative 1. That means y changed negative 3. My x's, I went from 4 to 1. It changed positive 5. So I could say the slope from a to b is negative 3 over 5. My slope from c to d, change in y over change in x. My change in y, I went down from 5 to 3, so I went down 2. And my change in x, I went from 0 to 5, so I went 5 to the right. So I get negative 2/5. And we can clearly see that negative 3/5 is not equal to negative 2/5, therefore not parallel. Okay, on 21, we need to find the measure of angle 2. Well, I have that right angle on the right side, so in that case, I know that this is also a right angle, which allows me to find angle 1, which is going to be 90 minus 38, which is 52. And then in order to find angle 2, angle 1 is a supplement to angle 2, so I'm going to do 180 minus 52, and that gives me 128, both B. In 22, which of the angles in the diagram are not corresponding? I start with 1 and 5. Those are both in the top left. Those match. 2 and 6 are on the top right. Those both match. 4 and 8 are both in the bottom right. Those both match up. But 2 and 7 are actually alternate exterior angles. They are not corresponding, so we're going to go with D. 23, we have parallel sides, which of the following does not have to be true. So here we're looking for the ones we know. Corresponding to work, alternate exterior, alternate interior will be congruent. If there's something that's not one of those, maybe a consecutive interior, which we know are supplementary, we could probably go in that direction. So let's see. 1 and 5 are corresponding. We know that works. 3 and 5 are alternate interior. I want to make a note here. Alternate interior angles. C is 3 and 6. Now 3 and 6 is, like I said, consecutive interior angles. And D is 1 and 4 alternate exterior angles. So like we said a minute ago, it's going to be C, because these don't have to be the same. These we know are usually supplementary. They could be the same. In that case, they'd both be 90, but we can only guarantee that they are in supplementary, so C would be our answer. On to our last page here. 24. We have AB is parallel to A is parallel to B, C is parallel to D, which does not have to be true. So we can go with some automatic ones first. Let's look at 3 and 7. 3 and 7 are corresponding angles. That's these two. 7 and 9 are alternate exterior angles. So we know those work. 5 and 7, well, those are a ways apart. Let's go back to 4 and 8. Now, if 3 was congruent to 7 and 7 was congruent to 9, we know all of those were congruent. We can follow that same logic and make 4 is congruent to 6, and 6 is congruent to 8, so that means 4 is congruent to 8, and that's kind of a transitive property using corresponding. So we'll write transitive and corresponding angles, which leads us to 5 and 7. So we know 7 and 9 match. 9 and whatever angles here, let's call it 10, would match, but that does not guarantee that 5 would match. We know that 5 and 7 would actually, if we worked our way through it, be supplementary, but not congruent, so D would be our choice. Maybe this one's a good example if you can find that every other answer does work except D, and that would be your reason to eliminate D. 25, we're looking for a reason in our proof. We're given that the sides are parallel. In particular, we're looking at angle 1 and angle 3 being congruent. So since it's the beginning of the proof, we have that 1 and 3 are congruent when given parallel lines. I think it's important to look at the answers and see they're naming the different type of angle pairs. So it's not necessarily a question of which is the step of the proof, but which angle pair is angle 1 and angle 3. And if we take that approach, it's a little bit easier to see that those are corresponding angles, so our answer will be A. In 26, we have all of our sides are parallel. Which statement justifies that 1, 2, and 3 are all congruent? Let's redraw this. Let's say I extended K, M, and N. Redrew line T. I'm looking at angle 3, 2, 1. So if all of these are parallel, and I'm looking at those angles, all of these answers start the same, but just like number 25, it's identifying what type of angles are they. Those are not alternate interior, they're not vertical, they're not alternate exterior, they are corresponding, so that would be our answer. Last one we have is 27. It says John believes two lines are perpendicular. How could you mathematically prove they are? We've talked about lines being perpendicular from their slopes. It's when their slopes have a product of negative 1. Product of negative 1, or we could say they're opposite reciprocals. If we look at the wrong answers, when they are the same, that means they're parallel. And you wouldn't have distance, because if we're looking at a line, we can't even measure the distance of a line because it's infinite. If it was segments, okay, that goes off in another direction and we won't see perpendicular and parallel. In that respect, what you need to know is parallel lines have the same slope, perpendicular lines have a product of negative 1, or they're opposite reciprocals of each other.